AP Statistics. All right, let's go into looking at 2.2 normal distributions and the density curves that go along with it. So in class today, we started to look at calculating the area under a portion of the density curve, particularly the normal distribution, using the table, using the calculator. So I want to do a few more examples of that here tonight, and also looking at using the calculator and how to go backwards, because that's also another thing that you'll be asked to do is, well, what score would you need to be at a certain percentile, at a certain percentage? So let's go ahead and dive into one problem. So I'm going to take a setup that was in the book. So hopefully you've read this section. So I'm going to start off with the following information. So we are told that Tiger Woods hits a bunch of balls during a tournament, and that the average distance that the ball traveled was around 304. Let me see if I can. Weird. Will not let me erase. Is 304 yards, and the standard deviation is 8. So we are also told that these data points form a normal distribution. So now the question becomes, what is the probability that Tiger Woods would hit a ball at least, okay, so something's up with my eraser today, sorry about that. So at least 290 yards. Okay, so as I showed you today, when you get these questions, always start by drawing a sketch of the normal curve. This should be always step one. So we hear the term normal distribution, I want to draw that visual. Okay, doesn't have to be picture perfect, but just something to kind of guide you. So, and I always like to mark, here's the mean, which we know is 304. So 290 obviously would be somewhere back here. So at least 290, meaning 290 or bigger. That's what that means. Okay. So that's what I want to shade in my graph. So I want to come over here and go, okay, I'm looking for this. So this is why, or a reason why I like to mark it on the graph, is now I visually see I have shaded more than half of the graph, because a normal distribution, the mean is right in the middle, right? So I see I've shaded more than 50%. So whatever answer I'm going to get from here has to be bigger than 50%. So this is important, especially if we're getting our answers from the calculator or the table, to catch myself of, oops, looking at the wrong side. So let's go ahead and do this by using the calculator. So I'm going to go ahead and pull up my trusty TI-84 calculator, and I'm going to do this side by side here so we can see what we're doing. Okay, so give me a second here to adjust. Okay, do that there, and we're going to switch up. So again, we see the background here. Where's the whiteboard? There we go. All right. Okay, so scroll this over here. So remember, to calculate the area under the graph, I'm going to go second and push the vars button. So I'm going into my distribution menu, and I want to select this option 2, normal CDF. Okay, so I can see where am I going to start to where am I going to end. So this time I see from my visual, oh, the lower bound starting from the left is starting at 290. So I gotta clear this out and type in 290 is my lower bound. My upper bound is positive infinity, because this is going to, remember, this keeps going on forever and ever. It'll keep getting closer and closer to the axis and never cuts it off. So the way, again, we type infinity for the purposes of this application is 1, and then I need that double E. So if you look, you'll see it where the comma is. So you go second E 99. So that's going to be a large enough number that it's practically infinity. Now for the mean and the standard deviation, we're going to enter the numbers that were given to us. So 304 with a standard deviation of 8. So I go and I paste, and I get my answer is 0.9599. So I'm just going to round that off to approximately 0.960. Okay, so we can leave our answer like that, or if you want to change it to a percentage, that's fine. So this would be approximately 96%. So approximately 96% of the shots that Tiger Woods takes would be at least 290 yards. Okay, now what if I was using the table? Okay, so what if I were trying to do this manually? So I'm going to do this example both ways. So now, to do it manually, remember the first step would be I need to get the z-score, because I got to standardize this 290. Okay, so get z-score for 290. So z-score for 290, so I'm writing it like this. And remember, it's score minus the mean score minus the mean over the standard deviation. So now we'll go ahead and figure that out. So again, I'm gonna do that in my calculator. So I'm not gonna pull it up here on the screen, but trust me that I'm doing it here on the side. And you should be doing it too, following along. So we get, it's exactly negative 1.75. So this is my z-score. So again, we talked about today, so what does this mean? That our number, our 290, is 1.75 standard deviations below the mean. That's what the negative means. Okay, so we got a z-score. Great. Now what? Now we use table A to get the probability. Okay, now here's the thing. So I'm going to go ahead now and pause for a minute while I pull up the table so that we can look at this together. Okay, so I got my formula sheet up. So here we go. All right, so remember we had a negative 1.75. So I'm going to go on to my z table here, and I look up and I go, okay, negative 1.7. So that's this row right here. So which number I'm going to want to pick? Now I need is the 0.5. So the 0.05, sorry. So that would be this number right here. So you see how it's negative 1.7. So it's this row. And then I need that second decimal place, the 0.05, and they intersect right here. So notice I look at this number, it says, oh, 0.0401. But wait a minute, that's not the number that we got from the calculator. Because what is this number reporting? That's what this picture up here is for, is to remind you the number that's in the table is reporting this part of the graph. That's not the part of the graph that I want. This is why we draw the sketch at the beginning. So now when I go back and I refer to my sketch, oh yeah, I don't want that. I want is the other side. So that's where I know, okay, I went to my table. So I'm going to set it up. I went to my table. So I know, okay, 0.0405. So that was according to our formula sheet. So again, I'm just going to double check that I got the right number. No, sorry, it was 0.401. So 0.401. But again, I want is the complement. I want the other side. So I'm going to subtract that from 1. So basically I'm subtracting the 4% from 100%, which is then going to give me the answer that I want, which was that original decimal that we got. So I'm going to just quickly do that here. So 1 minus 0.0401. So we get 0.9599. That's what we would get using the table. But you see, like, it's this we rounded anyways. So yeah, they're giving us the same value. Okay. So either way will give you the same results. Okay. So using either the tech or using the calculator or using the table. Now, I will preface one thing that I did not do up here. If you are going to use the tech to give you the answer, you have to show the syntax in the calculator. So my work for this is it. This is part of my work for the calculator work, but I have to write down, oh, what did I do? I have to write that, okay, normal CDF and the syntax that I typed. So 290 1E99, and then it was 304 with the standard deviation of 8. Now, this is not it. We still have to label what each of the pieces are. So right above it, I would go, oh, this is the lower end, this is the upper end, this is the mean, and this is the standard deviation. So I have to label my numbers. This is if you're going to do it just using the calculators, which most people will do. This has to accompany your work, because we have to know as a grader, okay, great, you did this. Great, I see this. How'd you get this? Oh, I put it in the calculator. What did you type in the calculator? Oh, this. What do those numbers mean? Oh, okay, and you got to label it. So this is very important. If this is not with your work, you will not get credit. If it's not labeled, you will also not get credit. Okay, so again, label stuff. So I said it with the graphs on the chapter 1 summative. Label axes, label your numbers. This is important. Okay, so that ends it for this first video. I'm going to put out another video where, again, using the same numbers, doing a different example. So again, if you liked it, if you found this useful, please hit a like, do the subscribe, and I'll catch you on the next video.